going to do logarithmic next, okay? So I'm going to do just one today. I'm not going to bombard you like in polynomials. I gave you 3, okay? So let's explore a little bit. I'm going to actually ask you to use your calculators. Exponential functions. So far we've covered polynomials with degrees 0, 1, 2, and 3. We actually didn't really touch on 0, but that's fine. It's a constant function, it's just a flat line. In this section, we explore exponential and logarithmic, okay? So let's start with a table of values. I know I haven't done this a whole lot, but here is an exponential function. How do you know it's exponential? Because the variable x is an exponent. That's how you know for sure this is an exponential function, okay? X is the exponent, therefore exponential. Okay, write that down, have that in your notes. I will probably do a study sheet entry after a day or two, but for now, just remember that. Another thing that I want you to be aware of, okay, that in general, let's do the general form. We'll talk about this a lot, right? But we call the first number A, and we call the base B, and x is the exponent, right? So you know an exponential in general looks like that. But I need to give you examples because the province gives you some wacky looking exponentials, but you have your calculator. So sometimes they have done this. They go negative 1.7, 0.25 to the x over 25. They've done that. They've put like a 25. It's still the exponent, but they have x over 25. No worries. We'll type it in. We'll just work with it. So I'm giving you a pretty wacko example here. We're going to deal with it. The calculator handles it, no problem. But the exponent is still up there, okay? So let's dive into these specific examples. So y is equal to 2 times 3 to the power of x. What we're going to do here is we're just going to take random x values because x is your independent variable. So what we're going to do is we're going to kind of think like, let's figure out a few points, plot them, and see what the graph would look like. So we're going to try 0, 1, 2, 3. That's good enough. I don't know if you remember in grade 10, 0 is always a good one to start with. Okay, so now then we have to figure out y. I will do the math here and then we'll put the value in here. Okay, so I'm going to kind of close this off here and I'm going to extend this table a little bit. Okay. So for the first one, when x is equal to 0, we'll go y is equal to 2 times 3 to the 0. This is just an exploration. We will not do this in general, okay? We will have tables. That we will have, but other than that, no. What is anything to the power of 0? What does that turn out to be? It's 1. Anything to the power of 0 is always 1. So this, like a million to the power of 0 is 1. Negative 500,000 to the power of 0 is 1. Anything to the power of 0 is always 1. And if you don't trust me, try your calculator. Ask your calculator, okay? I'll clear this. You go 3 to the power of 0, you'll get 1. So no argument there. So this is basically 2 times 1 is 2. Okay, so we'll put 2 down. When x is equal to 0, y is equal to 2. When x is equal to 1, so we'll go back to the original and we'll let x be 1. Okay, 2 times 3 to the 1. That's basically 2 times 3, which is 6. So when x is 1, y is 6. Let's keep going. X is equal to 2. 2 times 3 to the power of 2. That'd be 2 times 3 squared is 9. So that'd be 18. So 18. When x is equal to 3, plug that in again. 2 to the, what's 3 to the 3? 3 times 3 is 9, times 3 is 27. That is 54. So when x is equal to 3, y is equal to 54. Now, I don't know if you see any pattern. Sometimes it's hard to see. I'm going to use green and orange. Is orange called orange because of the fruit orange? Or is the fruit orange called orange because of the color orange? I don't know. Anyways, 2 is right here. So you will realize that every time what is this called, the 0.02? What do we call that in particular? What is that called? Anything with 0 and a number other than 0 is called the y-intercept. Okay, the y-intercept. So that number there happens to be the y-intercept, which is denoted by 0, 2. So that's the first pattern I want you to notice. Another pattern I want you to notice is, how did we get from 2 to 3 and then from 6 to 18? What happened every time? 2 times what gives you 3? Yeah, times 3. 6 times what gives you 18? 3. 3 times 18? 54. So one thing that I also want you to realize is that times 3, times 3, times 3, like we always went up by a factor of 3. Where do you see 3 on the original equation? It's right there in the base. So that's something right there that I want you to observe. The next part here, let's look at this function here. We'll try 0, 1, 2, 3 again. Let's make our table. This is on page 3. We'll do the math on outside of this. Okay. So when x is equal to 0, so basically f of 0 is 10 times half of 0 to the power of 0, right? Which is really 10 times, what's this going to be? Anything to the power of 0 is 1. So it's just 10. Are we surprised by that this is 10? If we look at the equation, right? 10 there, 10 there. And it is a y-intercept again. Interesting. When x is equal to 1, f of 1, 10 to the half to the power of 1 would be 10 to the half. So, sorry, 10 times half, because half to the power of 1 is just half. Yeah. Go ahead. So then you go 10 times half, or basically 10 divided by 2 is just 5, right? So we're going to put 5 here. We keep doing that. F of 2. Any prediction what the next number is going to be? 2.5? Yeah. 10 times half to the power of 2. That's 10 times 1. Guys, just remember, 1 squared is just 1. 2 squared is 4. So your fraction turns into a quarter. So it's basically 10 divided by 4, which is 2.5. What's the next one going to be? 1.25? You're guessing right. 1 over 2, sorry, to the exponent of 3. 10 times 1 over 2 to the power of 3 is 2 times 2 times 2, which is 8. That is 1.25. So this is 1.25. What did we multiply every time? What did we multiply this answer by to get this? We multiplied it by half. Right? Times 1/2 times 1/2. It's a little messy, I know. Try to make it work if you can. Okay, so let me ask you this. What happened to the y value as you progressed? Did it go up or down? Went up, right? What happened to your y value as you progressed here? It decreased. What is the difference? The difference has to do with the green, the number in here, inside the bracket. That is what causes something to go up or down. Okay? And the conclusion that we're going to arrive to is if this is, well, let's play around with it a little bit. Can I ask you to grab your calculator? Go to y equals. Turn off plot 1, right? We're entering a equation manually. Yes? That's correct. How did you arrive to that conclusion? It gets smaller and smaller and smaller. Guys, will this ever be 0 though? Because you can keep splitting any number, we can go on to infinity. You can keep splitting a number in half. And then keep splitting a number in half. There's this, it's kind of like a riddle or like an activity you can do. You want to walk from here to the wall, and what you're going to do is you're always going to walk half the distance that remains. Okay, so let's say it's 10 steps from here to the wall. I'm just going to take 5, right? Boom. And now 5 steps remain. I'll take 2.5 steps, right? 2.5. Technically, I will never touch the wall completely. I mean, you're like, you gotta be kidding me, right? Eventually you will, but technically not, because I just can't move that small of a step at a certain level, right? So you get really, really close to the wall, but you'll never ever really get there. So that's a very good point. We'll talk about that later. Can I ask you to enter this equation right here? So 2, bracket, 3, close bracket, and here you have to watch. You don't just go x like that. That's a linear. You want to go exponent and then x. Very important. You want it to look like that. And we're all going to look at the same thing. So I want you to go zoom, and let's do a standard zoom, like a 10 by 10, going each direction from the origin. And there's your exponential function. Okay? This is what an exponential looks like. And let's graph the one next door, this one at the same time. So what do you notice from left to right in this one? What do you notice with the function? Eventually, you come from the left, there's not much happening, but then all of a sudden, boom, you go up, right? Let's look at this one here. So let's go to y equals, go to y2, enter this, okay? 10, bracket, 1 over 2, bracket, exponent x. And let's graph that one as well. Which one is that one going from left to right? From left to right, it's going down, right? So that's something cool to observe. What is the y-intercept for this red one? It is 10. What is the y-intercept for the blue one? It is 2. It actually goes through 2. You could figure it out with your calculator if you needed to. Okay? So that's the cool part. So we've done our table. We've looked at our results. Right? We noticed that this is increasing, but this is decreasing. We can verify by graphing. So that's something I want you to keep in mind. Exponential function is not a quadratic. Okay, it is not. A quadratic function would come down and then go back up, right? You would see that, but this one doesn't. Okay. I want to explore for a little bit further, okay, on your screens. Let's zoom in to, it looks like it's riding the x-axis, correct? Would you agree with me? But is it? Let's zoom in. Zoom in, and let's go over to, how about this? We all go three marks over to the left from the origin. We zoom into that area right there. Press enter. And just keep hitting enter. See? As you zoom in, it's not touching. Okay? And this is that riddle that I told you about. Like, you can always still split the remaining distance in half, so it will never actually touch. It will never touch the x-axis, guys. Okay, never. Let's do a window here. I'm going to go x min. I'm going to go negative 1,000. We're going to go to the left and explore further. Because you don't believe me yet. I know that. I can feel it. I can sense it. Okay. If you follow, great. If you don't, that's fine. We're going to do zoom. Zoom in again. I'm going to zoom into that. It looks like it's on the x-axis. I'm going to zoom in a bit more, and I'm going to keep zooming in. I think this might be a long time until we zoom in enough to see that they're not touching. I just keep hitting enter. We'll be here a long time. Yeah, I can't do it. This calculator cannot do it. Desmos can do it, but I can't zoom in enough to see that they're not touching because I'm so far out to the left. I apologize. We hit the limit of what this thing can do. Okay? So you're just going to have to take my word for it. I'll show you later with Desmos that is true. Now, this is a study sheet entry right here. Okay, I've made this for your study sheet. Okay? This whole thing. And obviously we're going to make a smaller version of this. Here's something that I want you to remember, okay? Given the general form of the exponential, the first always gives the y-intercept, okay? That number that will be in place for a is going to be our y-intercept. Question, what if a is not there? Note, if you ever get this, y is equal to 2 to the x, a seems to not be there, but it is. A is technically 1, okay? A is equal to 1 there. So just make sure you understand that if it's just a number with an x, that there's a 1 in front of it, okay? A b determines whether the graph is increasing or decreasing. So this number increasing or decreasing, and this is how we know. If b is greater than 1, okay, if b is greater than 1, you will have an increasing function. From left to right, it's going to go up. Okay? And this is the one that students don't like this notation for whatever reason, but you just have to say, if b If b is between 0 and 1, it will be decreasing from left to right. Okay. It will be decreasing. In this course, we do not consider the case where a is negative. So a will always be positive. So I can tell you that already. A will always be positive. We don't consider negatives. So here's where I'm going to skip the graphing for now. Okay? And I'm going to ask you to go to 6. Page 6. So go to 6. Oh, sorry. Back to 3. I forgot something. It's important. It's important. I don't have this on the notes because the booklet, I updated it in the booklet moving forward. But there's you need to add this. Use a color. Use something that stands out. Because it never touches the x-axis, both of these graphs, and I would say just include it every time, it's an asymptote. Okay? Horizontal. And I always joke about it. It sounds like a swear word, right? You're a pain in the asymptote, right? You can use that. I do that so you don't forget about it. I don't like swearing normally. So there's a horizontal asymptote, and it has an equation. And the beauty is it never changes. A horizontal line is always denoted by y is equal to a number. And because it stays on the x-axis, it's always going to be y is equal to 0. This is the equation. I will make sure it's on your study sheet when it comes to that point. Okay? For now, you're going to have to remember or add your own note. So the equation of the asymptote is y is equal to 0. Never crosses the asymptote, right? I will add the note under this. The line never crosses the asymptote. Okay? And there's always one for exponentials. There's also one for logarithmic, but more about that later. Okay? Okay, so this is usually used for population growth, right? Like you start with a certain population and it just grows. You've done that in bio, I'm sure, some of you. And this one is more with decay, something that decreases over time. So coffee, right? In the morning, if I have my cup of coffee, I'm fully loaded with caffeine in my system. But as time goes by and as I drink water, it will slowly dilute, right? And it will decrease in your system. If you take Tylenol, radioactive material, it slowly decays, right? And some of you know what I'm talking about because you've seen it in other courses. Yes, it's coming back. Top of page 4. And I will summarize this all in one entry, hopefully. Characteristics of exponential functions. Both increasing and decreasing functions have an end behavior of Q2 to Q1. Think about it. Whether you're decreasing or you're increasing, you never cross this. You never go below the x-axis, right? So you're forced to go between quadrant 1 here and quadrant 2. Like you're gonna, if this is your x and your y, you're gonna be stuck between those two quadrants. Same with this one. You're gonna start in quadrant 2, but then end up in quadrant 1. Okay? So 2 to 1 works for either of them. So you know the end behavior is always Q2 to Q1. X-intercepts, the exponential functions never cross the x-axis, therefore there's no x-intercept. So listen carefully to this part, okay? If I give you a bunch of graphs and I say which one of these graphs matches this exponential function, please don't pick one where it crosses the x-axis. That cannot be an exponential function, okay? So that's not it. Don't copy this. I find space to doodle sometimes, okay? Y-intercept, the exponential function crosses the y-axis, therefore has one y-intercept. The y-intercept is always 0, a. Okay? The domain, what do you think the domain is of an exponential? This keeps on going to the left indefinitely, keeps on going to the right indefinitely. So, all real numbers. Pre-cal gets to not have brackets. It's not fair, right? But in applied, we have to have the appropriate brackets. So squiggly lines for this one. Interval, you do have to have your brackets, but I don't think pre-cal needs these squiggly brackets on there. But applied, we have to, okay? Range, this is new. This is new. Range. What's the lowest it can ever get to? 0, but it never touches 0. So guess what? Y is greater than, but not equal to 0. Or, watch this as well. It goes as low as 0, but it doesn't touch, so you have to do a round bracket. So for some of you, this is one of the few moments where a number doesn't get a square bracket. It gets as low as 0, and then it goes to infinity. Okay? Note, 0 infinity is wrong. Okay? Like you putting a square bracket instead of a round bracket is wrong. So that is something you need to watch out for. I will highlight this whole thing because this is new to you. Okay, you know what? I was gonna skip 4. I don't want you to graph just yet. I want to focus more on the word problems. That's the graph I want you to focus on more. But I will do one with you here. Just so you know, this one is actually y is equal to 1 times 3 to the x. Okay? I will rewrite it because this happens all the time. And students are like, well, what's a? Is a 3 or is a, what is a? Whatever is attached to the exponent is b. Okay? So a is 1, b is 3. Is this increasing or decreasing from left to right? Like imagine your graph. Is it going to go up from left to right or down from left to right? Increasing. Why? Because b is greater than 1. You either use this notation or you actually just write because b is greater than 1. Done. Okay. Domain. This one you can close your eyes and just say it's going to be this or this. No problem. The range. I hope that after today you know the range of this function. The range is y is greater than 0 or 0 to infinity. Round brackets, round brackets. What is the y-intercept of this function? The y-intercept. It is 0 followed by a. That's what it is. You can use your calculators. Yes, you can do second trace value x is equal to 0. It still works. It will always work. But I know that this is my y-intercept. 0, 1. And I will highlight the 1 here and match it with that one. That's where I got it from. I mean, guys, end behavior and domain is a no-brainer. What will the end behavior be? Which two quadrants does it always stay in between? 1 and 2. I don't care if you say Q2 to Q1 or Q1 to Q2, it doesn't matter. Like this doesn't matter which order you do them in as long as you tell me where the ends are. Okay? You're sliding down the slide or up the slide, it doesn't matter. Okay. Which fruit, by the way, loves going down the slides? Kiwi. Anyways, for now, you're going to leave those last two blank. I want you to, in pages 4 and 5, answer these questions all the way up down to end behavior, okay? And if it's a bit robotic and repetitive, I don't care right now. You just try it, right? You just fill that in for those 2 pages, all right? To be continued. Let me go over a couple, and then I want you to also learn how to work your calculator with these ones. This one is decreasing, right? This is A. If you ever, just making sure you understand, if you ever are making a comment about how these affect your final function or curve, make sure you identify which one is A and which one is B, either like this or you state it. But this one is decreasing because B is between 0 and 1. Anything between 0 and 1, you're not growing, okay? Domain, I should have at least scrambled these a little bit, but it's all real numbers. Range greater than 0. Y-intercept is 0, 6. And behavior Q2 to Q1. So that makes it very easy to work with these ones. Let's go to page 5 here. Yes, I'll work with these ones because these ones are a bit trickier. Let's do D. D right here. This is A and this is B. This is increasing because B is greater than 1. Okay? Domain, all of the real numbers. Not a word problem. Once word problems come in, this is going to disappear. Okay? This is going to disappear. Range, greater than 0. Y-intercept, 0, 200. And behavior, Q2 to Q1. Now, we're going to graph this thing on our calculator. And our goal in this course is for you not to blindly type stuff in and then hope for the best. We want you to understand what are you expecting in terms of graph, okay? So let's type this in and then I'll tell you further how to go about it. Okay, you type that in. Before you hit graph, okay, what do you expect to see? Let's do a little sketch here somewhere. It's never going to cross my x-axis below, so I'm not worried about this. This is going up from left to right, and it's going through 200 right here. It's going to do this. Okay, this is 200. So that's something you need to take into account. What does that mean? My y max, it has to be 200 is like not good enough even, I would say. You'd have to have it bigger than 200 on your y max for you to see anything. So let's give it a try. I'm going to graph. Oh, I still need to fix my screen. So I'm going to go zoom 6 for now. Zoom 6, I see that it's going up, but I need to meet it way up there, right? So window, let's customize. Y max, I'm going to go 500 or something way bigger than 200. And there you see it, right? You see it crossing at 200 and then it keeps going. Let's graph this now on our grid. So if I ask you to graph it, what are some points that are important here? Let's make sure you stay awake for this, right? X and Y. I need 200 on here. So I'm going to go 100, 200, 300. Okay. This is a point right here. Now the problem, listen carefully, the problem to exponentials is, do you have an x-intercept to go to on this one? Do you have an x-intercept? You don't. So where do you go to? Like, what do you do with that? Okay. I will tell you that I just try points. I try. So, for example, I'm going to go second trace value, and I'm going to try -5. If I go -5, I'm at 0.55. That's very close to the x-intercept. That's not a good one. Second trace value again, I'm going to go -2. So like right here. I'm at 18 there. So that will help me there. So I'm going to make this -5, -10, 5, 10. So I've just figured out -2 is at 18. This is, let's see here, 20, 40, 60, 80, 100. So I'm going up by 20s. So at -2, I'm right about there. I'll give you more tricks down the road, but I just did this myself. I found a point on my curve somewhere here that will help me out. You could have gone second trace value. You could have gone -1 if you wanted to. And that gives you 61. So how about that? -1 gets us to 61 right here. How many do you need, Mr. Dirksen? I don't know. How many should I? I would say at least 3, in my opinion, to get that shape that you need. So we come down from here. You go through here. You go through there, and then you want to curve away. And we'll just go arrowheads like that. This keeps going this way. We go arrowheads like that, and that's good enough, okay, for now. And I'll teach you how to do, and let me see if I can curve this a bit. It should technically go a little bit more towards the x-axis. There. And if you want to, I don't think it's required. I will figure out for sure, but you can draw your asymptote here. Okay? This is the y is equal to 0 line, your asymptote. Okay? But it never crosses it. Okay? All right. I want you to go to page 6. You'll practice more of this in a bit. But I want you to match these equations to these graphs down here. I want you to actually write down the equation underneath the graph. Okay? So match all 4 to the graphs, knowing things, right? So figure out your y-intercepts. You know what increasing and decreasing looks like, right? So can you take a moment to match those? And then I want to start word problems. Okay, so here it is, guys. This one is decrease. Like I know that this is decreasing because of B. This one is increasing, I know that. This one is decreasing. and this one is increasing. So that's already something you can narrow down, right? Here you have a y-intercept of 0, 2, 0, 4, 0, 4, and 0, 3. Okay, so those are things that you know right off the bat. So I have a y-intercept of 4, and I'm going down, so it's this one. This one matches this function right here, so I'm done with that. This one has a 2 intercept. There's only one of them that has a y-intercept of 2, so obviously this has to be that one, and it's going up as well, so that's, we can verify that. So this is gone. So now I'm left with these two. This one is decreasing and this one is increasing, so I know that this must be this one. And I see that it has an intercept of 3. So therefore, this has to be 4 times 3 to the power of x. Okay? So you have that there for you. I'm going to stop here.